Today we're working on right triangle trigonometry. You'll notice the calculator is in degree mode. Sine of 30 degrees is 1/2 and cosine of 60 degrees is 1/2. Sine and cosine are cofunctions. Cofunctions of complementary angles are equal. This is helpful. Today what I'd like you to do is grab a straight edge, some kind of straight edge, and a compass. You don't need a real fancy compass, but at this point in the semester you probably have located a compass. If you haven't, find one, borrow one, whatever you need to do. Let's draw a straight line. There's our straight line. And we're going to put a couple points right on the end. We have a straight line. What I'm going to do is I'm going to open my compass to the length of this straight line. Right about, there we go. So you can see it reaches this end as I strike an arc. And what I'm going to do is I'm going to carefully strike an arc like so. You can see what a big arc I struck here. I'm going to lift the compass and strike another arc, the same length as this line that we drew, like so. Well, that was fun. I have an intersecting point here of the two arcs, and an intersecting point up here of the two arcs. I'm going to put a little point on each one of those. It's actually this one that I'm interested right here. There is one below of the intersecting arcs. I'll just put a point there. A nice little reference. What I'm going to do is I'm going to take my straight edge and I'm going to connect this point to this line. It's true I could continue drawing it, but I just want to draw a little line segment. So when I do this, I'll place my straight edge on the 2 points, like so. And I'll draw in the line segment that I intend. There we go. Well, that was easy. What I'm going to do though is I'm going to examine the shape that I'd have if I joined all 3 points. Well, a triangle, of course. What kind of triangle? Well, what we'll notice with this triangle, we'll take our compass to take a look at the length of this side. Now this side, I'm going to call it 1 unit. And this length would be 1 unit, and this one over here, oh, my hand's in the way. Well, that'd be 1 unit also. So we call that an equilateral triangle. We just made an equilateral triangle. And I will put 1 right here because we talked about it being 1 unit. Well, what we've constructed when we found these 2 points of the intersecting arcs, we found that this angle in here was bisected. It was cut in 2. Because this started life, this triangle, as an equilateral triangle, all the angle measurements inside were equal. All of the angles added up inside a triangle summed to 180, making each one of these angles 60 degrees. 60 degrees. I've already cut this angle in half, so I'll put each one of the 30 degrees here, well, and here. I'll put a symbol down below to talk about 90 degrees. There we go. So now I can pick one of these triangles, one of the right triangles. I'm going to pick this one right here. And what I'd like to do is I'd like to find this length. Now because this is a perpendicular bisector that we had constructed, not only did it cut this angle in half, it also cut this length, which was 1, all the way from here to here, cut that in half. So this length is 1/2. So now I have a length of 1 and a length of 1/2. And what I'm going to find is the height of this triangle, the distance right here. This length is known as the altitude, or height, of this triangle. So we could use an A or an H. Either one of those would be appropriate. I think I'll choose an A. Now, because we have a right triangle, Pythagorean theorem applies, where the squares of the legs are added together and it'll equal the square of the hypotenuse. A squared plus 1/2 squared is equal to 1 squared. Let's see what happens when we work this out for A. A plus 1/4 equals 1. Subtracting 1/4 from both sides, we find that A squared is equal to 3/4. Taking the square root, I find A is equal to the square root of 3/4. So we have the square root of 3 divided by the square root of 4. The square root of 4 is 2, but the square root of 3, well, it's just the square root of 3. We're going to leave it in an exact form. Square root of 3 over 2. And that's what we had right here. The square root of 3 over 2. And we've got that side that we were looking for. Well, next up, I'm going to take a look at cosine of 60 degrees using our yellow triangle. Cosine of 60 degrees. Looking at our yellow triangle and identifying cosine as the adjacent over hypotenuse is equal to 1/2, our adjacent, over 1, our hypotenuse, which simplifies to 1/2. Cosine of 60 degrees is 1/2. While we're at it, let's look at sine of 30 degrees. Sine of 30 degrees, I'll locate 30 degrees. Sine is opposite over hypotenuse, or 1/2 over 1, which is 1/2. So here's a nice little demonstration why our cofunctions of complementary angles are equal.